bang there. Yeah, it's from the back, so you go. In research, there's no path which somebody tells you to go, especially in those parts of research which are unknown, and that's often the best. And so there you have to pick the right direction. You sure of this?
As I understand from Stefan, yeah.
Reinhard really has an amazing vision for where to go and what to do.
This is Reinhard Genzel and his team of astronomers from the Max Planck Institute for Extraterrestrial Physics near Munich. Today they're at leisure, hiking in southern Bavaria.
I make jokes that our PhD students ought to have been on a mountain before they finish, but that's certainly not required. Having a team of good people is absolutely essential.
Genzel and his team are credited with demonstrating that at the middle of the Milky Way, the Galactic Center, there is a supermassive black hole.
Our measurements in the end now are so close in that we can exclude any other configuration but a black hole. My interest in the Galactic Center started already about 28 years ago.
He was at the University of California at Berkeley then. Led by his mentor Charles Townes, the team there had already theorized there was something massive at the center of the Milky Way, maybe a black hole.
So the Galactic Center is somewhere in there, but unfortunately, between us and the Milky Way center, and that's 25,000 light years, is a lot of interstellar material. And you see this on this picture as these dark splotches. That's dust.
Astronomers have to overcome that dust, as well as the Earth's atmosphere, which blurs images. Genzel's team went to high-altitude conditions in the Atacama Desert in northern Chile. This is where the European Southern Observatory operates the so-called Very Large Telescope, or VLT. Actually, it's 4 telescopes.
There we have the best conditions to do our research with very big telescopes, 8 meters in diameter.
The telescopes can be set to see light at infrared wavelengths. Most light in space cannot be seen by the naked eye. Here's an example. This is Orion's belt seen in visible light. Then the same picture again, and gases not visible before show up in the infrared. At the center of the galaxy, the infrared neutralizes interstellar dust.
With the infrared, we can peer through this dust and make our measurements. Also in the infrared, we can use then the techniques of adaptive optics.
Adaptive optics was developed at the end of the Cold War by the U.S. military so that it could see more clearly in space.
If the Earth's atmosphere acts on the incoming waves of light coming into they bend it. So anything which was straight all of a sudden is wiggly. And the technique is to measure that wiggliness and then undo it through a so-called deformable mirror.
Here's the effect. This is the Galactic Center without adaptive optics.
Now switch on the adaptive optics, and all of a sudden your image sharpness is better by a factor of 20 or so. The astronomy has here, as it has before, benefited from applications in the military sector, which we now can use for these pure basic research efforts.
Genzel's team built a device for the Very Large Telescope in Chile that has adaptive optics. It gave them clearer pictures of the Galactic Center.
Yes, and that was really the key of the success. Make sharp enough images, beat the Earth atmosphere, which distorts the images, etc.
And there was some luck. Seeing more clearly meant finding a star not visible before. It showed the Genzel team there really was a black hole.
Star S2, we were extremely lucky, and nature gave to us, so to speak, a gift.
For 10 years, from 1992, they tracked S2, starting here at the top, when it was moving slowly, then all the way down. When it got to the bottom, it picked up speed as it went around the Sagittarius A star, identified as the best candidate for the black hole. The increased speed of S2 at that point confirmed that it was in a classic orbit of something massive.
The planets which surround the Sun, when they're very far away, go very slow. A planet which is closer by has to go more quickly. That's a basic result of gravity theory of Newton and also Einstein, of course.
The orbits of around 30 stars have now been traced around the black hole.
Nobody would have expected in the Galactic Center that there are stars moving around a black hole on time scale which you and I would call normal human lifetime scales. And so we surely couldn't hope that, but it was the case.
Genzel's team has been busy with more instruments. Sometime next year, the Infrared Space Observatory Herschel is due to be launched. Max Planck has built a spectrometer, which will collect the light that comes into the telescope on Herschel. It's also built a photodetector array, which will analyze the properties of the light.
This took us 10 years because it has never been built before. The whole instrument, starting from the detectors, the whole design, the material, etc., was a completely new development.
Every member of Reinhard Genzel's family has taken up science. His wife is Orsolia Genzel-Boroviceni, a pediatrician specializing in neonatology at a women's hospital in Munich.
I particularly take care of very small premature babies or babies who have trouble around birth and need to go on our intensive care unit.
When we visited, one of the Genzel's two daughters, Lisa, was writing exams on her way to becoming a medical doctor. The other daughter, Daria, stopped by to show her mother a new dog.
Well, I studied biology and did my PhD in the behavior and training of bats. Now I'm working as a dog trainer, mainly in the animal pound. And my main work there is to train dogs which have been very aggressive towards humans or towards other animals or towards dogs.
Here you can pick what you want to eat. I'll take a soup. Cheers.
Reinhard and Orsolia Genzel-Boroviceni put in long hours doing jobs they're passionate about.
It's cold, yeah. I think the kids are like that too because that's what they see around them. You know, they're always seeing us working, and even when they were little, my husband always took the work with him in vacation.
The Shaw Prize is not Reinhard Genzel's first award. In the past, though, he was slow to tell his family.
My family upbringing was do not brag. But I got into trouble the last time, so I guess what you heard was that I'm behaving a little better.
He's learned now that he has to tell me first because he once won a prize and I found out by a crazy person calling me at night. Our phone number is not listed anymore because people call and say they have been abducted by extraterrestrials and have seen the black hole, or, as I said, claim that had stolen my husband has stolen the black hole, like literally taken it and stolen it.
Yeah, that happened once before. Yes, black holes, apparently create quite a variety of responses.
Reinhard Genzel still spends about a quarter of his time working as a professor at Berkeley in California. Mainly, he's scientific director at Max Planck, which has some 80 institutes in Germany, including 3 near this one in Garching. Genzel likes the long-term funding here that's made special work possible.
Identify the key leaders who are likely going to bring that field, especially in innovative new fields, forward. And then let them research, no strings attached almost. It's a paradise.